common mathematical calculation in laboratories is for dilutions. And the formula is normality times volume is equal to normality times volume. This terminology relates to acid concentrations, but it could be anything. Concentration times volume is equal to concentration times volume. The example I want to use is 10 microliters of 2,000 parts per million. And we could call it, it doesn't matter, let's call it benzene. We have 10 microliters of 2,000 parts per million benzene, and we add it to 500 microliters, and this would be in methylene chloride or methanol or something like that. Normality times volume is equal to normality times volume. So our original normality is 2,000, our volume is 10, our ending normality is the variable, so this is our variable, and our ending volume is the 500 plus the 10, or 510. So the normality, you can quickly calculate this and find out that the normality is 39.2 parts per million. If the analyst wanted 40 parts per million, you'd have to run this as plus 490 instead of 500. And then that would make this a 500, and that would make this 40. My image of this is for an internal standard, and as an internal standard, you don't really care what the concentration is. And 500 microliters is a little easier to deal with than 490. Let's push this forward with just a little bit more detail. A microliter is a millionth of a liter, and since there's 1,000 milliliters in a liter, there's 1,000 microliters in a milliliter. So 1,000 microliters in a milliliter, 1,000 milliliters in a liter, so there's 1,000,000 microliters in a liter. A part per million is a milligram per liter is a part per million. A milligram per liter is a part per million. There's 1,000,000 microliters in a liter. There's 1,000,000 milligrams in a liter. You could look at this and say, but a milligram is a measure of weight, and a liter is a measure of volume. But one of the definitions that we use that's been around a very long time is that a cubic centimeter is equal to a milliliter, and it weighs 1 gram. So when we say that 1 part per million is a milligram per liter, there's an aspect of that as a definition, but there's also an aspect of that it's true and literally correct. The implication is that our liter is of water, and in applications, the liter usually is water. We're taking 10 microliters of 2,000 parts per million, and we're adding it to 500 microliters. 10 microliters of 2,000 parts per million is how many milligrams? Okay, remember that parts per million is milligrams per liter. So that the concentration is 2,000 milligrams per liter. We have 10 times 10 to the minus 6 liters. Recall that a microliter is 10 to the minus 6 liters. So we have 10 of them, so it's 10 times 10 to the minus 6. And if we multiply this out, the liters fall out, and we end up with 0.020 milligrams, and that is in 510 microliters. Remember that parts per million is milligrams per liter. And the way I start this out is I say, how many 510s are there in 1 liter? To find out how many 510 microliters there are in a liter, we simply divide that into liters. A complication, of course, is that we got to make sure our units match, so we change the 510 microliters into 5.1 times 10 to the minus 4 liters. As you all know, the units all have to match, and we end up with 960. And then our 960 times the milligrams in one of these gives us 39.2 milligrams. I think the take-home lesson here might be, what is a part per million? A part per million is 1 milligram per liter. And the normality times volume, it's nailed into my mind as normality times volume. But it's just concentration times volume. Concentration times volume is equal to concentration times volume. And quickly note that it's all directly related. That's it.